Hey everybody, Trey here. Welcome back to another video. Back with another forecast discussion today as we have a pretty potent severe weather event that is on tap for Monday and Tuesday of next week along the Gulf Coast. The SPC has outlined severe weather risk areas for both Monday, January 8th and Tuesday, January 9th. Here's the outlook for day 4, Monday, January 8th. They have outlined a risk area from southeast Texas all the way to the Florida Panhandle. Places like Houston, Lake Charles, New Orleans, Biloxi, Mobile, over to Pensacola under the gun for Monday. And then the threat shifts east for Tuesday. Places like Florida and Georgia up the eastern seaboard into the Carolinas on tap for a severe threat on Tuesday as the system moves east. Now, the SPC put out a risk on day 7 for Monday, which was a few days ago, and a lot of you were asking me about the specifics of this event, and I didn't really give very specific answers because we just can't at that point. And I really don't like to look at the medium to long range models that far in advance because they're just not that good at projecting outward accurately 5, 6, 7, 8 days in advance. But now is the time that we can start looking in, the models start to converge on a solution, and we can start coming up with some possible outcomes for this event. And that's exactly what we're going to do in this video today. We're going to compare a few models and their solutions from this morning, and then we'll come up with some possible hazards that you can expect if you live in these areas, and the overall, at least a general idea of the overall progression of the event. Of course, we'll know more. We're still a few days out, so we'll know more as the next few days progress, as we get closer to the event. But without further ado, let's go ahead and get started. We're going to jump right into the model data. We're going to be comparing model runs from 3 different models from the 12Z run of each. That was the morning run this morning of each of these models. We're going to be comparing the NAM, the GFS, and the European model. So we'll start off at 500 millibars. You can see we have a pretty decent looking trough here across the southern plains digging into Mexico. That is providing somewhat of a severe threat for today along the Gulf Coast as well, moving east into tomorrow toward Florida. It is a marginal risk right now for both days, but the threat is expected to remain isolated both today and tomorrow. Most of the robust convection, at least today, will remain offshore, but there might be some that makes its way just inland along the immediate Gulf Coast immediate coastal areas along the Gulf Coast for a brief tornado and wind risk, and that threat will continue into tomorrow, centered on Florida as well. But that trough is going to move out, and we're going to replace it with a much more potent trough that you can see digging down into the western half of the country by Sunday evening into Monday. Takes on a very neutral tilt by midday Monday. This is 18Z on Monday, so about noon Central Standard Time. Very potent trough, lots of strong flow rounding the base of that trough, 100 plus knots of flow there. Taking on a very neutral tilt at this point, the axis pretty much straight up and down, indicating a neutral tilt. This is indicative of a very high amplitude, very potent trough, and that is going to make its way into the southern plains and southeast, going into the evening on Monday into Tuesday. Now, with the NAM, we can't go out farther than 7 p.m. on Monday, so we're going to have to rely on the GFS and the Euro for our forecast on Tuesday. We can at least see how the NAM is showing the trough through Monday, which is the first day of our severe weather event. So we'll keep it here at 18Z, about noon Central Standard Time on Monday. Let's see how the trough progresses on the GFS. This is the GFS here. There's our trough digging down into the western half of the country by Monday. Here we are, 18Z Monday. Right off the bat, you can see a couple of differences in the overall geometry of the trough. And the position of the trough, though, is right on. So here is the NAM solution, center of the trough right there at 18Z, right on with the GFS. Usually the NAM tends to be a little bit slower with its ejection of these troughs. That does not appear to be the case in this particular setup with this particular set of model runs. But we do see a little bit of difference in the overall geometry of the trough. GFS progging more of a closed circulation here, perhaps more of a tightly wound trough, if you will. Still fairly neutrally tilted at this point. Again, this is about noon Monday. Going back to the NAM, we have more of an open wave here. Not quite as strong flow rounding the base of the trough, still potent. And this has some implications. This would have some implications on the low-level response. So the overall orientation of the trough is fairly similar, but because we have more of an open wave here, the NAM probably would not have as robust of a low-level response than the GFS would have. GFS, very tightly wound, closed trough, taking on a neutral to negative tilt as we go into the evening on Monday. So that would probably have a little bit of a more intense low-level response, which would mean stronger low-level wind fields to deal with on Monday, perhaps really enhancing that strong tornado threat. And we'll talk more about that in a second. And storm mode is going to play into this as well. But right now, it looks like the GFS has a little bit more of a potent solution for the 500 millibar trough. Let's look at the European model now and see what the Euro is showing. Once again, strong trough digging down into the southern plains. Here we are, 18Z Monday. So this is the Euro, GFS, and the NAM. The Euro is definitely on the train of thought of the NAM model, more of an open wave. Still with strong flow rounding the base of the trough. The Euro is a little bit farther back than maybe the other two models. There's our center on the Euro. GFS just slightly to the southeast, and the NAM is basically there as well as what the GFS was saying. So the Euro might be our slowest model here, not by much, not going to make too much of a difference. But here's the NAM, and if we go to 0Z, you'll see that the overall forcing, the exit region of the trough here, just starting to impinge on East Texas into Louisiana. That means that the timing of this severe threat may start very late in the afternoon on Monday and really maximize during the evening hours. We saw that risk area extended all the way over along the Gulf Coast into southeast Louisiana, Mississippi, Alabama, Florida Panhandle. That is probably going to be more of an overnight threat for those areas. We may see storms start to fire here across East Texas and Louisiana sometime in the afternoon on Monday, and then they'll work their way eastward with time. And that will maximize the threat in the evening to overnight hours for places like southeast Louisiana, southern Mississippi, Alabama, into the Florida Panhandle. So, of course, that's always very dangerous in the southeast. Lots of trees hampering visibility for these storms anyway. The fact that you have it at nighttime, that may make it an even more dangerous severe weather event. So right off the bat, it looks like timing is going to be a little bit later than what is typical. So here we are, GFS, 0Z. Again, the trough is still back in here, exit region in here. So that means your forcing is only going to be here, East Texas to Louisiana by 0Z, 6 p.m. Central Time on Monday, meaning that your severe threat is going to maximize overnight. Same thing with the Euro model. So all the models look to be pretty much on the same page. Just some slight differences in the trough geometry, but it looks like all models start to close off here. The GFS earliest with the closing off of the trough. Euro definitely by 0Z has a nice closed circulation here at 500 millibars. The NAM still the probably least potent of the three models, but again, it's not going to make too much of a difference, maybe a little bit of a difference in the low-level response. We'll take a look at that here in just a second. You do see that the trough does start to take on more of a negative tilt going into the evening on Monday. With the NAM, GFS stays pretty much neutrally tilted. But again, I would expect with time that would continue to take on a negative tilt, and you do see that it does start to wind up a little bit, take on more of a negative tilt going into Tuesday morning. And here we are with the Euro, much of the same solution. So let's go down to the low levels here. Let's start off with moisture. We'll just look at the surface moisture fields here for these three models. And so as we talked about, there's going to be a severe threat, a marginal severe threat, but still a severe threat today for the Gulf Coast states going into tomorrow. That is going to be ahead of a cold front that is sweeping through, and that is going to allow the moisture to be swept out a little bit into the Gulf. Now, we can't look at the moisture here on this particular European model from College of DuPage, so we'll look at the NAM and GFS for this. And I'm going to zoom in here to our southern plains sector so we can get a better view. But again, that cold front is going to sweep the moisture out into the Gulf a little bit. So you see here this morning, we start to see a little bit of those 60s and 70s dew points here, making their way almost to the shore, to the coastline here of Texas and Louisiana. But you see those dew points start to drastically drop off going into the evening tonight into the weekend. And that is because we have a little bit of a cold front that will sweep those dew points out. Those 60s and 70s dew points are going to be relegated well into the Gulf. You see them off your screen here by this point. So that is one possible fly in the ointment, is that the moisture is going to be well out into the Gulf, and we're going to have to bring that northward. So that is going to depend on the track and intensity of the surface low. If we have an intense surface low with a favorable track here, that's going to start to really pull that moisture to the northward, which is what these models are showing. But if we have a little bit less robust of a surface low, less robust wind field in the low levels, we might not quite see far enough northward progress for the entirety of this risk area to be to come to fruition. We might see it, if that we don't see as robust of a surface low, it might be cut off a little bit. But overall, this is what the consensus is showing, and we do see at least decent northward progress of the moisture going into the into early next week. So here we go. As we go into Monday, you start to see finally those 60s dew points come around. We don't have 60s dew points here on the NAM model, and this is at 6Z Monday, so midnight going into Monday morning. Those 60s are just starting to creep into southeast Texas, and we see that rapid moisture advection northward. We'll take a look at the actual surface pattern here in a second, but we do have at least a small warm sector here make its way inland by 18Z. Again, the forcing may lag behind a little bit, but this makes its way inland. Forcing starts to arrive by about late in the afternoon to early evening on Monday, and so we will have a severe threat that begins probably late Monday afternoon into Tuesday. But you can see that the warm sector is fairly confined here to the almost not quite the immediate coastal areas, but it doesn't make its way too far inland. And again, this is as far out as we can go on the NAM. So this is 6 p.m. Central Standard Time on Monday. Very confined warm sector here to kind of the coastal areas and just about half of Louisiana and far southeast Texas. That would be our only chance for a robust severe threat at this point, given a confined warm sector to those areas. Let's look at the GFS now. So let's go forward in time. You see those dew points, those purples and dark blues swept out into the Gulf with that cold front, and we don't see that return flow starting until Monday evening to Sunday evening, early Monday morning at the latest. See that moisture, a little bit farther west moisture return on the GFS compared to the NAM. Let's go back to 18Z. So you see that the NAM is there. GFS, actually it's about the same here, so pretty similar progression to the moisture, at least among the NAM and the GFS. And we do see a little bit more robust of a northward advance of that robust low-level moisture. So that goes back to what we talked about. The geometry of the trough on the NAM was not quite as potent as it was on the GFS, which means a little bit more robust of a low-level response on the GFS, and therefore a farther northward advance of the moisture. Anywhere we get this robust moisture, that's going to be where our severe threat is. So it's all going to depend on how far northward that robust moisture gets with this setup. That's going to define the northward extent of the severe threat for this setup. So you see going into Tuesday, Monday evening into Tuesday morning, that warm sector, and I'll move over to our southeast sector now. That warm sector does keep itself inland a little bit into southern Mississippi, southern Alabama, Florida Panhandle. GFS may even have a few severe storms up here farther to the north of the Florida Panhandle. SPC outline does have it going up into southern Alabama, southern Mississippi, and the Florida Panhandle. So we could see this definitely reflects the GFS more than the NAM. The NAM is certainly not quite as robust with the moisture return, at least from a northward extent, than the GFS is showing. So that would mean a more robust severe threat farther north if the GFS solution comes to fruition. All right, let's back this up here. Let's look at our surface low, and we'll go back here on the NAM as well, and we can do that on the European model as well. So we'll look at how our surface low develops over the next several days here. So we'll start, this is again the NAM run from this morning. So yeah, surface low oriented right there along the coast. That's going to bring our severe threat for today into tomorrow. That'll move off to the east, shunt that moisture eastward. And you'll see that we have some cold air behind it, these greens and blues in the 30s and 20s there across the southern plains. So some cold air behind it. Not a super robust injection farther south with that cold air. Then we start to see surface low development. As that trough makes its way across the Rockies, we'll get lee cyclogenesis on the east side of the Rockies. That will help to really start pulling that moisture northward by Monday evening or Sunday evening into early Monday morning as those winds switch around and strengthen out of the southeast. That'll pull that Gulf moisture rapidly northward. And we should see that inland advance of the warm front, the northward extent of the moisture return. And that, again, will confine our severe threat. That will define the northward extent of our severe threat. So that surface low meanders along the Red River into southern Oklahoma by Monday evening, at least on the NAM. You see it is kind of a broad surface low. We have a couple different centers possibly in here, and that may be convectively influenced there, that lobe, that center over Arkansas into the northern Louisiana. But it's a little bit on the disorganized side. Still a tight surface low, allowing the surface winds to back and strengthen there, pulling that moisture northward, increasing the low-level shear out ahead of it. But it is a little bit more disorganized. I would expect the GFS to be a little bit tighter of a surface low. So let's look at that now. Let's go back to our southern plains sector, and we'll go forward in time. So you see that surface cyclogenesis there by Monday morning. Pretty tight surface low there across eastern New Mexico to west Texas into the Texas Panhandle, making its way eastward. And we do see that for sure, especially as we go into the day, into the evening hours on Monday to Tuesday morning. We have a little bit more consolidated of a surface low here. Still a broad surface low, maybe a couple different centers in here. Again, that eastward center could be convectively enhanced, but it is a little bit more tightly wound. This is 6 p.m. Central Time on Tuesday with the GFS with the NAM. So NAM, GFS. You see it's a little bit more tightly wound here, a little bit tighter of a pressure gradient, helping to really strengthen those surface winds a little bit more and back those surface winds out of the southeast a little bit more than the NAM, which would lead to more robust moisture advection to the north and robust low-level shear. And I apologize for using the word robust a lot in this video. As you can tell, it's probably one of my favorite words to use, so I apologize for that. But here we are, GFS, and let's see what the Euro shows as well. So again, we get cyclogenesis across eastern New Mexico by Monday morning, moves off to the east, and here we are by 0Z, 6 p.m. Central Time on Tuesday. So a little bit of a difference between the models with our surface low orientation. This European model would be a little bit different as far as where our severe threat would set up. This looks to be a little bit farther west than the other models. This is our surface low center here in western Oklahoma on the Euro model. Here we are on the GFS, surface low center down to the south, and perhaps another one here to the east. And then we have our NAM run, which is right in here. So a little bit of a difference in the positioning of the surface low, and again, that will modulate where our severe threat sets up. With the European model, that does appear to be a little bit on the slower side compared to the NAM and GFS, so that would push the severe threat a little bit farther back to the east. Timing would be a little bit... Timing looks to be a little bit delayed maybe, given a slightly slower progression to the upper trough and surface low. But overall, the idea is the same. Surface low develops, and we get that moisture advection northward. And again, it's going to depend on where that moisture advection ends up, which is all dependent on the track and intensity of the surface low. GFS looks to be the most robust at this point, which is unusual. GFS likes to be a little bit more on the less tightly wound side, a little bit more progressive side, usually. Not the case with this particular event, but certainly a strong surface low. With this GFS model, cold front would be somewhere in here. So cold front looks to be somewhat of our initiating boundary. And we do have enough room, it looks like, for a severe threat out in the open warm sector. If we go back to our dew point map here, GFS certainly has a decent amount of real estate here in the warm sector, which could provide a line of storms along the cold front and some convection out here in the open warm sector. We'll look at that in just a second. Probably a little bit too early to really peg that down, whether or not we'll have an open warm sector severe threat, but it certainly needs to be watched, especially going into Tuesday morning as that warm sector shifts east. So let's take a few soundings here from the warm sector. We'll go 0Z, so 6 p.m. Central Time on Monday. We'll take one ahead of the cold front with each of these models. Let's go back to the dew point here. And again, a little bit less robust warm sector on the NAM. And we can't take soundings on the European model, so we'll look at the NAM and the GFS. So this is our NAM model, 6 p.m. Central Time on Tuesday. First thing we notice, deep moist layer. So that quality of the low-level moisture is not going to be an issue here. It looks to be very deep low-level moisture, up to about 700 millibars. Usually we want that to be deeper. That gives a lot more of a juicy low-level and mid-level air mass for these storms to feed off of, and therefore that can allow for a robust severe threat. Problem is, with that kind of saturated low-level environment there, that tends to decrease the low-level lapse rates and decrease the instability overall. And you see our instability is a little bit on the thin or skinny side here. We do have about 1,200 joules per kilogram of mixed layer cape on the NAM, but it is pretty skinny. Oftentimes we like to see that fatter cape, which allows for more robust updraft, stronger updraft intensities, and a more robust severe threat. With these skinny type of setups, that can decrease the strength of the updrafts just a little bit, and so we'll have to watch that for sure. Let's see what the GFS is showing thermodynamically. A little bit better thermodynamics here. Very decent instability, pretty much the same as the NAM, 1,200 joules per kilogram. A little bit on the fatter side for sure, not quite as saturated in the low levels, which means there might be a little bit more drier, a little bit more of a batch of dry air aloft, which could mean a little bit more robust updrafts. Mid-level lapse rates about 7.1 degrees Celsius per kilometer on average there, which is pretty solid, especially for a southeast event this time of year. Going on the NAM, we do see a little bit of that as well, 8 degrees Celsius per kilometer in the mid-levels there. So especially as you go above 700 millibars, the lapse rates look pretty decent. And so instability is going to be probably right around 1,000 joules per kilogram or so, which is more than adequate with strong kinematics in play. Now, one of the questions with the instability is going to be ongoing convection in the Gulf during the day on Monday. Let's go down to our convective precipitation here. So we're not going to look for any, anything we would look for on a convective allowing model, look for supercells or squall lines here. This is just going to show us the precipitation that is formed by convection, robust thunderstorms. So let's go ahead and do that on the GFS as well. And you'll see here that these models have a tendency to produce a lot of convection over the Gulf in the warm advection regime leading up to this event. So this is 12Z, so 7 a.m. Monday, or 6 a.m. Central Time Monday. This is 9 a.m. Central Time Monday. You can see a lot of convective precipitation over the Gulf of Mexico. That is a potential fly in the ointment with this setup, because what that is going to do is that may thwart the inland advance of robust moisture with this event. We, again, have the pretty strong surface low in play, which would allow for that moisture to come inland, but this convection may disrupt that moisture field, and we may see a little bit of a challenge as far as getting those robust dew points inland. So that is one thing to watch. If we have a lot of convection in the Gulf throughout the morning and afternoon on Monday, that may thwart the overall severe threat a little bit. That will keep the instability down. And that could be a potential fly in the ointment for decreasing the intensity of the severe weather threat on Monday. Let's see on the GFS as well. Let's go to the GFS, convective precipitation. And once again, you see a lot of convection fire up over the Gulf on Monday morning. So that could be, again, problematic. If we have a lot of convection, that's going to disrupt the moisture advance northward into these regions. And that could, again, decrease the intensity of this event. You see a lot of that convection persisting into the afternoon hours across the Gulf. And before we get that the convection to intensify along the cold front ahead of the surface low. So we're going to have to watch that for sure. That may be a fly in the ointment with this event, and that may bring the instability down a little bit. But right now, as we sit, even with the convection in the Gulf, we are still seeing mid-60s dew points make their way inland with some decently steep lapse rates allow for a good chance at robust updrafts. Now let's talk about the kinematics here. Again, this is at 6 p.m. Central Time on Monday evening. So we do have a little bit of curvature there in the low levels of the hodograph, but these hodographs are pretty wonky. We see a drastic amount of backing of the winds above 850 millibars. That's not always a bad thing. That can vent the precipitation off well to the north for any discrete supercells to really have a nice visible tornado threat, or have nice visible tornadoes out of any supercells. We don't see a lot of curvature there in the low levels, and that backing occurs pretty low in the atmosphere, which the lower this veer back signature is, the more detrimental it can be to the setup. Now, I won't go into the details of veer back veer in this particular video. We'll do that at another time. But these wind profiles are a little bit wonky, certainly not super favorable for an intense tornado threat yet. Same thing on the GFS, very minimal low-level curvature there in the hodograph. Speed shear certainly maximized here, about 10 knots at the surface, increasing to 40 plus knots there at about a kilometer, to about 60 plus knots there at 700 millibars. So the speed shear is certainly there with this setup. That would support strong deep layer shear for supercells and line segments, and we'll talk about the storm mode here in just a second. But for a significant tornado threat Monday evening in the warm sector, doesn't appear to be much of the case, at least with these particular model runs. So why don't we talk about that now? Let's go ahead and look at the overall storm mode with this event, at least on Monday. So here we are with the NAM, and right off the bat, you see here is our initiating boundary, cold front likely to initiate storms, and you see our shear vectors are oriented very much parallel to that initiating boundary. And as we've talked about many times before, when those shear vectors are parallel to the boundary, that allows updrafts to go up along the boundary, stay in that zone of ascent, and you'll get a lot of updrafts to go, especially with a progressive cold front, which we should have here. Given strong forcing, that cold front should get shunted east pretty quickly. And given the strong cold frontal forcing and the line cold front parallel shear vectors, that should create a pretty quick transition to a linear mode. Let's look on the GFS, see how that looks as well, and you see much of the same there. Shear vectors very much parallel to the cold front, which is our initiating boundary, meaning more of a linear mode. So this looks like it's going to be more of a quick transition to a linear mode. Again, we'll have to watch out in the open warm sector whether or not we have any confluence bands or anything to possibly have a little bit weaker forcing for more discrete supercells ahead of the main line along the cold front. Let's look at the NAM for that. GFS not quite as high resolution, so we won't be able to see much from those GFS runs. But let's see if we see any confluence bands in the open warm sector, and not really seeing a ton here. Maybe a little bit of weak confluence out here across Louisiana, southeast Louisiana, into Mississippi. We'll have to watch that for sure. Not seeing huge signs of super notable confluence in the warm sector. But again, there is enough real estate, especially on the GFS, that if we get warm sector supercells, they might have a chance to be more discrete out ahead of the main line and perhaps would be able to tap into more of that tornado threat. But again, right now, the tornado threat looks a little bit limited this early in the event, which would be Monday evening, again, at 6 p.m. Just taking a couple soundings out in the open warm sector, that is much, much better. So along the cold front, those winds probably start to veer quite a bit as the cold front approaches. You have the cold front approaching, and those winds will start to veer out of the southwest, really decreasing that low-level shear. But out in the open warm sector, that is not the case. Much stronger low-level shear, much stronger curvature in the hodographs, over 350 meters squared per second squared, effective storm relative felicity. In the NAM sounding here, even more on the GFS, that is really impressive. Strong, strong curvature there of the low-level hodographs there on the GFS. So that would favor a strong tornado threat. If we can, again, get discrete supercells out in the open warm sector, that would certainly be favorable for strong tornadoes. Here on the NAM, a little bit better instability out in the open warm sector as well. 1,800 joules per kilogram mixed layer CAPE. A little bit fatter instability there in the mid-level. Strong mid-level lapse rates, over 8 degrees Celsius per kilometer. That is very strong, especially for a southeast event. You don't see that often here. Still very moist low levels. This would certainly be a sounding capable, an environment capable of producing strong tornadoes. But again, it's all going to depend on whether or not we get open warm sector convection. And the tendency for that may increase during the overnight hours as that warm sector shifts east. If we look on the GFS here, you see that warm sector shifts east. East does shrink a little bit in size, still enough room for some open warm sector convection, maybe impacting the Gulfport, Biloxi, Mobile areas by about midnight on going into Tuesday morning. Take a sounding out there right about the Mobile area, out ahead of the cold front. So again, the convection along the cold front will have a damaging wind threat as well as probably some embedded tornadoes, little brief kinks in the line. But out in the open warm sector, again, if we can get discrete convection, this would certainly favor a strong tornado threat. Over 1,100 joules per kilogram mixed layer CAPE and strongly looping hodographs, decent amount of low-level streamwise vorticity, which would increase the significant tornado threat with these supercells if they can form. So going into Tuesday morning now, let's go ahead and shift to our southeast sector. That line will continue to shift east along the cold front. And again, we'll have to continue to watch for any open warm sector development. So this is the GFS. You see on Tuesday. So the GFS has a pretty quick degradation of the instability, at least inland, especially across Georgia into the Carolinas. GFS does not have much of that instability going up into the Carolinas. And that is a little bit different than what the SPC had outlined. Again, we can't go forward with the NAM. So let's look on the European model and see our theta E, just a combination of basically temperature and moisture. See if we see any of that in the European model, certainly more robust with the instability up into the Carolinas, which would favor a tornado threat and damaging wind threat up there as well. So let's take a sounding from the GFS here. Let's go from the Florida Peninsula here. This is 18Z Tuesday, so right about midday on Tuesday for the Florida Peninsula. And we'll see, and that is pretty impressive. Those wind profiles are super, super strong. Limited instability farther to the east, it looks like. Again, this kind of remains in question as we do have some model differences among the medium range models here over where that warm sector will set up for Tuesday. But those hodographs, strong speed shear in the low levels, not a ton of curvature in the low levels, but overall strong deep layer shear favorable for supercells. Possibly ahead of the cold front. Again, we'll have a line of storms ongoing ahead of the cold front, and whether or not we'll get discrete convection is up in the air. So that's going to do it. That's just at least an initial video on the overall threats with this setup. Again, we have a severe weather risk outline for Monday and Tuesday, and that extends from the southeast Texas area all the way along the Gulf Coast to western the western Florida Panhandle on Monday. And then we go into Tuesday. A little bit of discrepancy among the models, but right now the SPC has an outline from the Carolinas southward through Georgia and to the Florida Panhandle and Peninsula. So again, it looks like we'll have a pretty quick transition to a linear mode along the cold front with the potential for some discrete supercells out in the open warm sector. We'll know more as we go through the next couple of days whether or not that is going to be a good likelihood. But given strong forcing aloft, with that trough coming in, we have a nice broad area of strong flow aloft that could provide just enough forcing out in the open warm sector for discrete supercells, and we'll have to look for any confluence bands out in the open warm sector as well. But right now, it looks like a squall line will take place, and again, this northern edge of the severe threat depends on the intensity of the surface low and the intensity of that northward moisture return. If we get a more robust surface low, that'll mean more intense northward moisture return, and we'll see that severe threat perhaps persist farther north than what is forecast. If not, we get a little bit weaker of a surface low that will be a little bit more confined to the coast, but still we'll have a strongly favorable setup for significant severe weather. So on Monday, looks like things will start up in the late afternoon hours along the cold front as that warm sector shifts inland. We'll have a line of storms along the cold front, quick transition to a squall line, given shear vectors that are parallel to that initiating boundary, strong frontal forcing, a quick transition to a squall line, and again, the potential for discrete supercells out ahead across places like southern Louisiana into southern Mississippi, Alabama, the Florida Panhandle. That will maximize itself overnight, Monday evening into the overnight hours Tuesday morning. Threat shifts east on Tuesday. Cold front storm squall line will continue into Tuesday morning from the southern Alabama, southern Georgia into the western Florida Panhandle, into the Gulf. And again, potential for discrete supercells out ahead of that. We'll have to watch that for sure, as the kinematics with this setup are very, very intense. Certainly favorable for strong tornadoes, strongly looping hodographs in the low level, strong deep layer shear for supercells with adequate instability. We'll have to watch that for sure, and we'll know more again over the coming days. So if you live in any of these yellow shaded areas here, definitely keep an eye on things over the next couple days. I'll be back with updates as needed over the next couple of days. And again, the models will become a little bit more aligned with each other going forward, and we'll get a little bit more specific information going forward. Keep those weather radios handy. Stay tuned to your local National Weather Service office and the SPC for the latest up-to-date information, and we'll get through this event just fine. So with that, thanks for watching, and we'll see you in the next video.